Today, just to revise, we learned about exceptions and how the exceptions appear and why do they appear and how do we mitigate those exceptions. So, exceptions are nothing but an unexpected um, flow where we reached some sort of error. Yesterday, we looked at division by zero error, and you can also raise your own errors and things like that. So, these errors are inbuilt, or these errors are um, implemented in Python so that you come to know some of the common errors, and also you can implement your own exceptions. So if there is no file and you're trying to open the file, then you can get file not found error and things like that. So we looked at the syntax where we have try and except block is the mandatory ones, and then we have two more keywords which are like finally, and then there is else. Finally gets executed when whatever the case. So in any case, finally gets executed. Else block gets executed only when there is no problem in the program flow. So this exception doesn't occur, and else um, gets executed. So important things to remember is to understand what traceback means. So yesterday we looked at how the program um, is actually run in the uh, on the chip. So and then how operating system sort of comes to know what is the how do I put that program onto the RAM and then help CPU to pick up the instructions. And then we also looked at something called a stack, and functions gets stacked in that particular stack, and then it gets unwinded as we uh, get out of the function. So traceback is nothing but it's like unwinding all the pieces or the frames in the stack and then putting it out. So that is called as stack unwinding. So that is the main concept behind this exception. And we looked at various cases. Okay, I'll make a PDF of this and send it, and I'll also share the Jupyter notebook so that you can try this on your own. So, okay, today we will learn something about modules and packages, and we will also learn, if time permits, we will also learn about unit tests. So, coming uh, coming to modules and packages. So, what are modules? This is more related to how do we organize the code. It is nothing related to logic and algorithms or anything like that. This is one of the ways that we can organize the code in such a way that it matches with our design and architecture. So I'll just give you an example, and then we can look at how do we realize that in code. So in any software that we build, so generally we sort of break that into modules. So when we are brainstorming, we make that into like blocks of um, functions or blocks of uh, functionalities, and then we sort of draw these boxes and lines. So this interacts with this, and this interacts with this both, and something like this. Okay. So and then this is if if it is language independent, so we can call it as an architecture. So it involves a lot of things, but architecture talks about how functionalities are um, separated and what are the interfaces between the major models. For example, what is the uh, interaction between your browser and the server? Is it a REST API? Is it some remote method invocation or something else? Or is it a SQL query that you are sending and getting something? So these interfaces are defined at architecture level, and then comes down to say browser. So if somebody wants to make a part of browser, and maybe we divide browser into multiple sections, say tabs, and how open the tabs and close the tabs, and then probably there is cache and several. So you can list out all the functions, functionalities, and then you sort of draw the boxes and then make it interact with them. So at till this point, we haven't um, written any code. That means design is a part where we sort of put our mental model onto the paper, and then we translate that into code. So let us take a simple example. For example, I want to develop a calculator. So calculator is a is a requirement. I want a calculator. So how do I write software for this? Probably I can easily open say some calc.py and start writing code from here, and I can write all the functionalities in one file. So when I do this, what happens is that, so if there are any new functionalities, for example, initially I have only say add and subtract and multiply and division. So there can be a requirement saying that, okay, I want scientific calculation. So I can use all these modules plus the scientific module. So which could be having something like tan theta, cos theta, and all the trigonometry functions, and probably some more exponents and all these things. So then if I start writing this into this code, and code grows big, probably thousands of lines of code. So how do I divide, not uh, at the time when I write the code, but it is advisable, or it is easier to divide the code or the modules in such a way that all these are separated and it can be reused. Of course, there is from the Python execution point of view, if you can write in one file and execute it. But when we write code, it is not only us that is using the code. That means I can probably, I'm working in a team. I can write add module. Somebody else is writing subtract module, and somebody else is doing something else, and so on. Maybe somebody else is building UI or things like that. So there are multiple people working, and also people are changing. People may move in and out of teams. Probably they move out of the company, things like that. But the code needs to be in such a way that it needs to be structured for anybody who opens the source code folder. He should understand that, okay, there is some relationship in between these functionalities, not the functions, functionalities, requirements, and then they are translated to the structure of the code. So that is how we sort of give a hint about the design looking at the code structure. So you can look at any of the Git repositories. I'll just show you some of the repositories just to give an idea how code is organized. You can go to GitHub and close this. We clear the drawings. So you can go to GitHub and you can go to, say, let us take this. There is a library called as Celery, and let us take a look at how this is organized. Okay, so you can see that there are several folders, and there are some files here, configuration files. There are YAML files, and there's a file called contributing and readme, and there are several things here. And then if you go to each of these modules, say folders, Celery, and then you can see that code is organized in folders. And again, inside that, there are folders inside that and things like that. So looking at this, you can somehow make a mental model of how this probably, if you know a little bit about, like if you have read that initial document, which is readme.md file, and come to this folder structure, you can roughly sketch that, okay, there is something called as worker. So we do the mental, when we read this, it's like mental model, right? So worker is there, and then there is consumer, and probably consumer is part of this worker, and there is agent under this, which is part of this consumer, and this is consumer and this is agent. So now, just looking at the folder structure and the files and even the file names, we come to know that there is some sort of structure which gives us hints to travel through the code or navigate through the code. So that is the reason why we write modules, and these folders are called packages. I'll come to specifics in a while. But yeah, this is how usually the code is organized. So that is the reason we need to have modules in our mind, because we do not usually write one single file and get out of it, right? We generally write a lot of files and break that into modules and uh, come back and then modify it. And the duty of architect or the code reviewer is to make sure that we don't nobody messes up the folder structure, because you're essentially trying to uh, give a different mental model for the people who are coming later, right? So we should make sure that this code remains here and this code remains here, and then we and sort of they interact with these functions which are called interfaces. So that is about modules. And what do you mean by packages is packages are nothing but collection of modules. So if you compare C, C++, and say Java. So in Java, there is something called as, like, you might have heard about jar files. So those are all collection of like lot of modules within which there is a there is Java compiled code inside that. So similarly in C, C++, there is something called as .so, which is shared object. And then when you install something, there are like a lot of SO files, which are libraries. And then all these SO files are kept in, say, one folder, which is sort of a package and things like that. Similarly in Python, so when we write a file, any file, it is called as module. So module is nothing but collection of functions and variables and then probably classes. So this is how the module is defined. But it is just a mental model of like how the functions are separated. And then collection of several such modules, module 1, module 2, and module 3, several of this. And then if I keep that in a folder, it becomes a package. So this is like a simple concept, like functions put together, module put together, package. That's it. And how do we create those? Is just creating folder becomes a package, creating a file becomes the modules. Okay. So that's just the mental picture of what we are learning today. And then how do we create is actually say, let me take this and let me add a function. Uh, have the code already here. Where is the... So I'll just copy this and copy these functions. So these functions are just like related to calculator, and I'll put it here. These are the functions. I'll call this, instead of add.py, I'll just call it as cal.py. Okay, there is already calculator. Fine. So this, I have created a file called as calc.py. You can see that if you have ID, if there is something like this red mark, that means there is some problem. Here we have an indentation problem because I copied from Jupyter Notebook. You can actually indent all of this. And I have functions, and you can see that I'm not calling any function here. So if you want to use this function, obviously we do this, right? This is how we call the functions. But I want these functionalities to be used somewhere else. So I'll create, say, user.py. Okay. So how do I get all the functions which I have defined in calc.py? I'll open here so that this is visible. How do I make sure that all this code is I can access this code here using import? So you can simply say import calc. So it automatically IDs automatically detect the files, but let us see what import means. When we import the calc, let me just print the calc and let us see if we get any error. You can look here in line number 2. I'm just printing the calc. So this is when it doesn't have anything to print. For example, it cannot print all the functions, right? So it tells that module from calc. So clearly it says that, okay, this is a module from a module called calc, and module name is the file name itself, except the py from this particular directory. So this is how we sort of um, import it. So how do we use it is just using, say, add. So let me just try to add two numbers, and I'm able to use here. Okay. So as you know, in Python, when you try to execute any program, execution starts from line number 1. Okay. So when it imports in line number 1, it sort of puts all the functions in a bucket, and then it uh, goes to next statement and does something. So this is an execution, second line of execution. So when it does this, so it is aware of whatever we have imported here, and then it prints it, and then it goes on. So now you could be writing functions. For example, if I want to use user.py in somewhere else. So let me create a file, um, user.py. So let me try to utilize this particular user.py in this new user and see what happens. And import user. So once I import this, so without doing anything, let me just try to run this. You can see that it picked up user.py, and I have not called anything, like I have not implicitly invoked this, but this gets executed. That is because Python is an interpreter. So it executes line by line. When you import any file, it just finishes the execution. How do we avoid this, and how do we make sure that it just imports? I do not want this to get executed when I import. So how do I do that? When we import the modules, so the module itself is called, uh, the module where I'm executing is called main module. So I'll show you how. So I can tell that, and also I want to test this user.py separately. So I should be able to execute this user.py separately. And when I import, I shouldn't get the error, saying not the error, in the sense I don't want it to execute in one shot. So how do I do that? Is like this. Use Close this. So there is something called as uh, if this particular module. So I don't have to remember this. Just get used to this. So name is an inbuilt, um, you know, inbuilt variable which tells that what is the name of this particular module. So if the name of this particular module is called as main, only then you do something. Say I'll put this in function def. Um, so now you can see that I can invoke this user.py independently, and this call me gets invoked. So let me just put it here for the clarity. So let me just comment this. So when I execute this file with this block or without this block, it doesn't matter because its output is the same thing. I'm just calling it, calling a function. So when I try to execute this, so it has gone here, line number 1, line number 2, and line number 5, it gets executed. So in order to avoid that, I'm going to use if this particular module is this, and let us try to execute from new user, which is a new module, and try to, now you can see that we do not have print from here. So this code gets executed only when I specifically run this file. So when I run this particular file in this main, the main becomes this main file. So that is the reason that, okay, this current file is, the name of the current file is main, and it simply executes. So name and main, all these things are already there inside the, whenever we create an object, we get a lot of goodies from Python, right? So whenever we create a class or object, there are default functionalities that we get from Python. So one of the default functionality is like the name of that particular module. So that is how we create a module and import a module and avoid module to get executed when we import. So most of the files, if you see, so generally it will have probably, I'm not sure about this, but yeah, it will have some sort of main double underscore and things like that. Yeah, they're not testing this independently, they're testing somewhere else. But yeah, generally, if you're writing modules and which you want to test, you can write that modules. You can look for examples. You can simply do a search and find it out. So this is about module.
Sorry. So ideally, every module that you create must have
Must have.
that the
No, no, no,
main.
no, 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 it is not necessary. It is not necessary. Only when you want to call, you want to invoke this function as well, user.py, sorry, user.py module as well. You want to use this independently. Like, for example, you want to test this call me and you want to see some prints without actually importing. You are working on this particular modules. Imagine that all of us are working on different files, which are modules, and you want to test this. So how do you test this without like unit testing? So like
Okay.
independently test this, right? So this is how you do. And I don't want somebody, when they import my file, they don't want all my test cases or all my function calls get executed. So I want to avoid that. That is the reason I'm telling that, okay, if this is not main, this current file, main, main means current file of execution. If the current file's name is double underscore main, only then call this. So when we import that particular module, so this becomes main file. The name of this file or the module will be something like new user dot double underscore main. So that is how we avoid. So if I'm using your file, I do not get this particular thing, because it is just a normal if condition saying that if something is not matching, do not do this. So this doesn't match when I call here, so it doesn't get executed. Clear?
Yes, thank you.
So, okay. So that is about, this is quite simple in Python, but in C++, there is a dependency, and then there is, you have to create SO files, and you have to keep it in certain directory. There is hash include some .h where header files needs to be defined, and so many other things. So in Python, it's just quite simple and straightforward. And if you want to create packages, you can simply create, say, my package, just a folder. And let me try to move this directory into my package. Okay, so let me try to run this. Now you can see that we got an error saying that there is no module called as calc. That is because we moved um, calc to my package folder. So how do I use when it is inside the folder is simply like this. There are different ways of importing a package. So while using packages, there's slightly different. You can use this format to call this from my package. This is how you sort of import from a folder from my package, import calc. So there are different ways to import. So I'll just show you. Clear this. So this is just for code organization. So so you can import a module like this, and you can also import some of the particular uh, functions inside that. So you can, if you want, just say add, you can also use something like from iPackage dot calc import just add, and you can use add here, but in line number 4, we're trying to use calculate um, add it, but it is just add here. You can see that I'm just using add. Let me try to call another function which is inside this, which is a divide or multiply. And see what happens. You can see that it tells multiply is not defined. That is because we haven't imported entire module, but we have just imported one of the functions. You can import multiple functions like this, or you can simply import all the functions in one go. So that is also possible. And also sometimes what happens is probably there are developers who might have named the modules in this as same names. So what happens is other file has add, and probably another file guy has written some other functionality, say string addition, or another guy has written integer addition. So when I try to import, that's from the same package. So when I try to import, it leads into conflict. And in Python, whichever gets added once, so it takes the first one, and then we won't come to know what's happening. So in such cases, we need to sort of add an alias. For example, math operations. If there are two models called as math operations, we can call it as MO1. Second one, you can call it as MO1 and things like that. So this is called as aliasing. As is aliasing, and yeah, you can also import all the functions just using star as well. If you are using just math operations from operations import calc, you'll have to call using that calc dot add, calc dot multiply, and so on. So if you simply do this, so this is not advised. That is because in this, when we read the code, we won't come to know from where this module is coming. So when I search the code, like using Control F, so it won't show me. There is no definition in here, but it's difficult to find out from just from the bare eyes saying that okay, there is a star and then there is a lot of import. So do not use this unless there is a proper intention to use this, but usually use with proper way of variables and proper functions. So this is about functions and packages. We'll talk about init file. So before I think 3.5 version, so there for every module we should be adding one double underscore init file. So it looked this, like this. So this tells us, this used to tell that this folder is a package. So this is how the Python used to differentiate between normal folders and Python specific folders. But later on that feature was moved out and said that, okay, you can include any package, and then it is up to you whether to use the Python modules inside that. So also init.py is a file where we can define some initial actions. Say, for example, I want to initialize some resources, say open some ports and do some resource allocation. You can do it in init file. So it's like initialization stage. We can still use it, but it is not mandatory. So that is about init file. So this is just a this lesson is just about organizing code. That's all. So this is how typically a project looks like. We saw one of the examples. So there is my project and there are multiple folders. So now if you look at the folder structure, you come to know that, okay, so this is how the design is, the rough design. And when you get into each of these modules, you look at the functions and then see that, okay, this is how the function calls are getting called, and those are the interfaces. So how does data or models communicate with data? How does utils communicate with data and things like that? So this is how we sort of form a mental picture, and it is very important to split the code into multiple modules and packages. Uh, Say if you just go on a vacation for one week and come back and look at your own code, it looks quite strange because we might have forgotten the implementation. So there needs to be some sort of agreement between the developers and saying that, okay, this is how it is structured. So this is how the normal. So you can put everything in one file and start doing it, but it is difficult to say, what if I want to create a new software which probably uses I just want one of these modules. I don't want everything. So how do you migrate to such a thing? So that is the reason we divide things. It is just like we actually do it in day-to-day life. For example, if you are organizing books, so probably you organize all the books in storybooks in one column and organize all the technical books in another column, and so on. So this organization concept in our mind is translated to code. So as we learned earlier, so code is nothing but our realizing our thought patterns um, in the on the code. Okay, so that's a it's not a difficult concept here. So that's about modules and packages. So these are code structure is necessary when you try to create your own model. So how about there are several modules which are not implicitly, or it's not there in the Python default installation, but you want to import. For example, I want to connect to a website and then download some output from that. So that particular um, module is not there in Python. So it is called as, say, requests, and you want to download that. So how do you download that? Is there is a command called as pip, and you can install, say, requests. Okay. When you do that, I have already installed, but let me install, say, it's not there. So if okay, so how pip works is it tries to connect to a server which is hosted um, on the internet, which is usually the python.org, and then it has several repositories. It has its own way to identify the repository, and then you can install any module. So once you install, you can also install for a particular version as well. And for example, I'm working on a project. I'm working on multiple projects wherein I have different requirements for modules. For example, this project uses request library, and some other project, say data science project, I have some pandas and things like that. Those are the libraries which are used there. So in fact, you can download all the packages in one go, saying that install each package here in this current um, folder, or current folder that you're working on. Or you can also do something called as virtual environments. So that is where the virtual environments come into picture. You can, so I have created one virtual environment here called as env. So here, so I'll tell you what does virtual environment mean. So wait, okay, spelling mistake. So uh, forget about deactivate for a moment. So this is a terminal where I'm trying to execute the code. So if I'm working with multiple projects, maybe I have multiple folders here, and probably multiple windows of this VS Code. So it doesn't matter how do you open, but once you have this project, so I want specific modules for this particular project and specific modules for other projects. So if I start installing everything, your library gets, your folder gets sort of mixed up. And also, it is also possible that in this particular project, you are using a certain version of a certain module. For example, requests, say some 2.11 version here. And in other project, you probably use old version, say 1.0. So both of the libraries cannot coexist uh, in that particular folder. So how do you separate your modules with these libraries? So that is where the virtual environment concept comes into picture. So virtual environment is quite a simple concept. When we create a virtual environment, what happens is now we have uh, so far what how the packages gets installed is it depends on what machine you are working. So Linux, Windows, or MacBook. Generally, there will be folders for libraries. And Python, when you install Python, so it goes into certain, say, bin Python. So when you invoke Python here on the terminal, what happens is your operating system searches for where is this um, executable, that I can execute. So it cannot obviously search all the directories whenever we run the command, right? Because it's costly, costly on computation. Searching is like it takes a lot of time. So where does it search? It searches for specific location. So that specific locations is defined in path variable, $path. So this variable is part of OS environment variables. So this is defined for every terminal and every operating system. So when you install Python project, right? So it will ask, should I add this to path? So which means that, okay, should I make operating system aware that add a link of this Python to this particular path. Okay, so that is how operating system comes to know that whenever you try to execute a command on your terminal, so it is coming from this particular location. So when you create a virtual environment, what happens is, so this usual path, we do not anymore refer to this by default path, but we create our own path. Say I'm creating some folder structure here, wherever I create venv, some name. This is not fixed. You can name it, say my env, or that project name, or anything like that. And then in this particular folder, it creates its own bin directory and install the versions of the Python that you want to use. So in fact, you can have Python 2 here and Python 3 in different environment. So you can look at this particular directory, penv. So let me just close this. You can see here, there is some extra directories that I have created, and it gets created. So, and there is something called as activate, and then there is something called as, so these are all the libraries that I have installed. For example, when I installed Jupyter, I did pip install Jupyter, so it comes here. So this is just a alternate folder that we create in order to access different versions of libraries or different versions of Python. So that is how the Python virtual environment works. So you might think that environment means it's like a process running, and it is totally different from usual Python execution. No, it is not. It's just a copy of your um, different version of libraries and Python. So when I installed, say for example, if I simply, how, so if now I have different environments, how do I know that which environment should be picked up for this particular project? So that is where this particular file activate um, comes into picture. You can simply paste it here, and there are different commands to execute. So in sometimes if you simply execute that um, activate, it gets executed. In Linux, we use either sh, which creates a shell and then executes. Source executes that particular um, script directly here. So you can see that this is a shell script, and it has its own way to, it has its own code to activate this. And you can see that it is setting, in one of the lines, it is setting path variable, which we learned just now, to this particular path, because this particular path needs to be added to this variable, so that operating system knows that when you invoke Python, this is the Python version I need to call. So this is Python virtual environment. So you can create as many environment as you want. This is, in fact, it doesn't need to be in the same folder as such. It can be in any other folder. Usually, you can create folder for just the environments, and you can create the folder for just the projects, and you can invoke those environments whenever you want. But in generally, how do we organize this environment is that in the folder of the project, in the beginning of the project, uh, we can have a folder called as that virtual environment. So let us see how we can create an environment. So let me get rid of these drawings. Okay. So when you activate an the environment, so you get different um, prompt as well. So this will change. So that is how you come to know that okay, there is a change in environment. So if you open another terminal, and if you are working on different project, so this environment name will be different. That is how you know that okay, I'm working on this project and this is related to this particular project. So clear all drawings. Close this. Let me deactivate. Wait. So these are the commands. Activate and deactivate is to you is the way we use to activate that. So when I activate, it just does this. So this is the main line that you need to remember. But there are several other things that it does. It changes the PS1. PS1 is nothing but this particular string that you see in the terminal. So you can change. So for example, PS1 is equal to, you can see that I have this is also one of the operating system variable, and then it changes this particular thing. So I'll just show you how we can create an create virtual environments. So there is something called as, so if I say, so you can simply do Python -m venv. So what does this mean is I'm invoking Python. -m is actually calling a module. So this is as good as we are importing uh, here this packet, this line, these lines. So it invokes this particular module, which is inbuilt for when you install the Python package, Python installation. Download the Python and install it, and then you can create, give any name. For example, this is a class and class environment. So if I just do this, I have to select it. This is a feature from IDE saying that okay, I already have a environment. So do you want to like create one more? So but when you do it on a plain terminal, it doesn't come. So this is IDE's intelligence saying that okay, do you want to overwrite it? I'll just say yes so that I can demonstrate. So it has created this environment. So how do I come to know that this is created? You can see that we have a new folder got created called as same class -env, and we have bin, and it has activate, and you can also see there are some basic Python executables here. And let me just show you how. So now if I creating environment doesn't mean that you have activated the environment. So you need to activate this particular um, thing. So you need to uh, go into that folder or just copy the path and then say that activate this environment. So when I do activate, so you can see that the prompt got changed. PS1 got changed. So this this is how we sort of, by looking, we know come to know that okay, we are in this particular environment. So how do I install packages only here? I'll just show you. Pip install. So you can see that previously we got an error saying that not error, we got an output saying that it was already installed, because in that environment requests library was already installed. So now it is collecting the requests, like it goes and downloads that package and then installs it. So then it tells that okay, installing this particular package and this version and so on. So this is about we install this. So now look at what is happening to this particular folder. You can see that there is a library folder in this class env. So there is a new folder got created, requests. So now you can see that we learned about modules, right? So somebody has written this particular package called requests, and you can see that there are several modules inside that. Certs, auth, compact, cookies, exceptions, models. There's so many things here. So this is how, if somebody, in fact, you can find out the source code of request library. For example, Python request library source code. So this is the source code of this particular request. So it almost matches what we saw, right? So for example, this folder, source folder, and then there are API, auth, certs, compact, exactly what we are seeing here. So it doesn't go to GitHub and download. So GitHub is like just a repository, right? Somebody, people are trying to write code and add features on top of this. This is the history of, say, one of the files, and a lot of people are collaborating here. So this is just a code repository, and but there is also you know uh, some place where there is a sign off here on GitHub, or any place where we sort of sign off that there is a release. So this code gets picked up for release, and it becomes part of say that particular release. And then there is a documentation and all of these things. So this is how usually we do the software deployment, right? We write code, we have some sort of versioning for releases, and then we release it. We do not directly take the code and just release, right? So there are several testing and acceptance testing, integration testing, so many things happens in the backend, and then this is just the code. But this is, if you want to like contribute to request library, you can actually clone this particular request library, and look at the code, understand it, and look at the features, and you can actually contribute. So once you contribute, so it's not like you contribute and it goes into the repository, right? So somebody needs to verify your changes, make sure that the current code does not get affected in a way that it is not intended. And then somebody merges your code to your this particular main branch, and only if it gets merged, it will become part of the request library. So anywhere in the world, somebody downloads request library like we did, it will have your own code. But to get into the like these sort of popular open source projects, you need to be like someone who is uh, you know, good in coding, and there are levels, like there is contribute dot uh, there will be some file which tells that how you need to how you need to write code, and there is some sort of agreement, say this is how you need to check in the code and test your code and all these things. Yeah. So yeah, that is how the open source works. So that open source is one which sort of enables us to download Python and libraries and a lot of other things, right? So this is how the packages are installed, the relationship between your virtual environments and then different virtual environments and activation of that virtual environment. So in order to deactivate, there used to be a script called as deactivate. Then people thought that, okay, we don't require deactivate file. We can simply have a command when you activate that particular deactivate particular environment. You can also create a deactivate command which will automatically deactivate. So you won't find the file called as deactivate, but you will be able to call deactivate command. So this is how you activate and deactivate the uh, virtual environments. So any questions here? So if you want to like try out, just do this particular command. This will do create virtual environments.
For some reason, that gave an error.
Uh, which
Um, yeah, Python -m.
What is the error?
It says syntax error, invalid syntax. I don't know why.
A syntax error. I shouldn't be. So, is it possible to share your screen?
Sure, sure. You have disabled screen
Okay.
sharing.
Yeah. Let me 1%. Yeah. Try now, please.
So basically,
No. Okay. You are inside the interpreter. So, like you have opened Python. Just okay. Yeah. You are inside. Okay. Let me annotate and show you. Okay. So this particular thing, right? So you're trying to execute here. So this is an interpreter. Like you have opened Python, and then you are trying to do. You don't need to do this. So this is just to invoke your interpreter, but you don't need to invoke your interpreter. So you can simply
okay,
type Python -m and things like quit from here. So if you see this, this is not required. Yeah, this is your when you open the terminal, this is your base
okay.
this one. So you can type here, yeah, M module venv virtual env and name it as some your own, yeah, test. It's great.
I had tried installing the Jupyter notebook as well.
Okay. So
Even
how
that
Jupyter
didn't.
Notebook works, just to give you a brief. Usually, Jupyter Notebook, how do you use it normally is, okay, so let us just get done with this. So yeah, now it has created. If you open this particular folder, uh, here, no, open folder here, it's you're in a different directory. So you can actually open C user solution folder directly here using open folder. You can simply click on or do ls there, or dir, yeah, if it's Windows. Yeah. So you can see that there is a folder got created called, there is a test game here. That's there.
How do I import it here in?
Yeah. So you can click on this, like open folder, this particular. Are you able to see the?
Oh, here. Okay.
Yeah. Click on this. See here. Yeah. See users here. Yeah. Yeah, in fact, you need to create, yeah, you can open the whole folder. This is there already, but what you can do is you can create a folder called as a Python learning or project or something like that, and this can be in a different directory. It's not a problem. You can get into this directory. Can you do cd test -v? Yep. Yeah, okay. ls dir, and you can get into scripts, cd scripts, ls dir, and you can simply activate this. Just type activate. Okay, there is batch activate. Go up dir or just dir or activate dot bat in yeah, just activate dot bat. Yeah, let me just Windows activate uh, command. There is something like source similar to Windows. Give me a moment. Let me look at. Is there a caps activate dot ps? Okay, dot ps1. If it's a, I think it's, if you have opened a oh, it's a PowerShell. There is ps.1, same folder, ls dir. There is activate.ps1.
That's okay. Case sensitive.
This command was not found. Why? Can you open a different terminal? Okay. You can actually open the folder.
Mm.
Don't need to open a folder. It should work. Or it's the, and it's this character one. Can you do just dot activate? Dot activate. I think there is a way to run command in dot space, I guess.
A is caps.
No, in Windows it doesn't matter. Uh, Git bash. What is this? Can you click here? Here, add a new terminal. Here, or open CMD direct. This is PowerShell. Okay. Uh, can you navigate into the same this one? Which version of Windows is this? Is it
This is 10.
um, okay, okay, there is an issue. Can you use call space activate?
Yeah, that's what I checked.
Uh,
Is that somewhere?
yeah, there are different ways to activate.
With path, I think. With the whole path.
Full path, is it? Okay, try.
Yeah. All space.
PWD. It will give the
PWD space.
PWD, just enter. It will give the path. Okay, copy that path. Yeah, and slash activate. Backslash activate. And yeah, call, same thing, call. In the beginning, use call.
You mean here?
Yeah, yeah. Okay, let me. Okay, there is some problem. I was looking up Stack Overflow. Can you try?
Can you type the path in between double quotes?
Yeah, so that's what I'm looking at. It's,
So sorry. What is that, Sima?
The whole path between double quotes. Call space, double quotes in between path.
yeah, let us figure out how.
Okay.
But yeah, usually it shouldn't take. But
I mean, I got some error for
call
while installing Jupyter
Ah,
Notebook as well. I couldn't figure out. Yeah. I think we are already
yeah,
uh,
sorry, yeah. Sorry for
it's
holding it
8
up, but
o'clock.
yeah, it
Yeah.
should. Yeah, just look up.
Sure. Sure.
And
Try to figure it
should
out.
be just executing that command. So
Yeah.
it's
Thank
basically
you.
runs that script. Okay. Everybody else, please try to do this. Yeah. So this is how you do the version.
Digan,
Yeah.
I will share my screen, just Jupyter and Python.
Sure. Yeah.
So I install Jupyter nodes.
This is Jupyter templates.
Oh,
It's not PI, it's PY. Search for GUPY. Sorry, not G.
GPI and PY.
Yeah, TR. That's correct. Jupyter. Y. Y. Okay. So this is just an extension that you're enter. Okay, this is click on that this one here. That extensions here this one. This is so you're here click you're here actually, but yeah, you need to click on Jupyter notebook here.
Here already installed templates.
This
So
one.
not template.
This one. Just click on this.
Okay.
PY Jupyter. Yeah, here. So this is JUPY.
So GUPI.
Yeah, this one. The first one. Remove. Go back. Yeah. This one. Yeah. First one. Yeah. You can install. So by doing this, you are not actually installing Jupyter. This is just a plugin so that your editor can find out Jupyter. So installing Jupyter is on the command line. You have to type pip install Jupyter, like here, pip install JUPY TER and hyphen notebook, I guess. So yeah, just enter, remove the hyphen, enter. Yes. So after this installation, this your Jupyter plugin detects that and uses that. Generally, in a vanilla type of Jupyter installation is like you need to. Okay, I'll tell you how to open that. Yeah, so all the dependency packages gets installed. You can see that there are so many dependency packages.
It's just pip install Jupyter, right?
Yeah,
Digan?
it's getting installed. Yeah, just pip install Jupyter. It's not PI Jupyter, it's PY Jupyter. It's getting, it's just a warning. Yeah.
Mhm.
So usually yellow is warning and red is the error. So warning is still okay. Once you install that, you can simply do this command.
Yeah.
Installation is complete. You can take this command in the chat is or type just Jupyter py Jupyter Jupyter. You can paste it on the command line. Jupyter space notebook note, yeah, correct, yeah, book, enter. So when you invoke this command, what happens is Jupyter Notebook works on it opens a port. Jupyter is not recognized of same relate. You need to add this Jupyter to okay, just go to close the or restart this
Yeah.
this one. On Windows there is some difference between PowerShell and other shells. Just open it again. So yeah, you can, yeah. So you need to set in Windows, you need to do this. So you can look up the internet. So
Yeah. I will look.
yeah. So what you have done is now you have installed the Jupyter Notebook in Linux, and I think even on Windows on some shell, it automatically adds this Jupyter command to directly to the path. So, but now it has not done in this PowerShell. Maybe it is intentionally PowerShell is designed like that. I don't know, but yeah, you need to invoke this particular Jupyter. So if you just look
I
up
will
the
Google it.
internet, there is a way to add this into path, and then it should start.
It opened the local the Chrome instance for me, Digant.
Yeah, so if
What
it opens the Chrome instance, that is correct. So how Jupyter works is it opens the port, and then you can actually open, you can click on that, add a notebook. So let me just show you on here. So on any terminal, so I think Jupyter is not here. Oh, it's there. Oh. So from the terminal, it opens. Okay, it opened in different monitor. I'll just show you here. So you might be seeing like this.
Yes.
Jupyter notebook. So this is like properly installed and path is configured. You can actually open a new notebook here, and then you can say start writing your code. And then in order to execute, you can click on this and it starts executing. In fact, you can copy like Jupyter notebooks from outside world and you can open and start writing. So this is the vanilla version of Jupyter. So, but when you install Jupyter extension, what happens is, so I have installed a Jupyter extension. So this detects this port, and whenever I save a file in that particular format, it automatically detects, for example, here, exceptions. So even if this, I do not need this terminal, I can, when I open this, it in the backend, it opens the port. So we won't come to know. So this is actually like a web page, but it is embedded inside this VS Code. But this is the port that gets opened by default, and it gets embedded here. So that is why we don't see this browser when you try to use extension, and you need to save a file called as ipynb. It's like IPython notebook, something like that. So if it is in this format, since you have installed extension, it automatically opens the port and starts the Jupyter notebook, and then you can like try it directly. But it is essentially the same thing. So it's the same port, and you are using this here. In fact, you can write it here as well, or you can do it here as well. So I can open say so these are called cells. So you can open new cell, and there are different types of cell. One is markdown, which is just the text, and reload notebook from the disk. Save. Okay. Once I open the port, it doesn't tell me. It opens in that particular folder, so I'm not able to see anything here. Cancel play. Okay. So this is the one which I opened. So the folder from where I started the Jupyter notebook, it becomes a root directory here. So if I go and open any of this, say for example data types, now I have got the Jupyter notebook, and you can see that there is text and there is also code. I can simply click on this particular cell and click on this execute. So it gets executed. And you can also like clear all the reset the kernel, which is like reset the port, and you can also stop execution. And I think there are more things to do, like clear the output, and you can change any of this, and then hello to. So this is not executed, so there is no output here. You can click on execute and it gets executed. So this individual cells, which is like this particular block, gets executed. So it's basically a port which gets opened, and it actually communicates through this port. So since it has opened the port, by default it opens in any browser, default browser, which is your Chrome. That is why it has opened. Okay, give it a shot. Yeah. Is it clear?
Yeah, yes.
Thank you.
Okay, yeah. Thanks for staying. Okay, yeah, and okay, that's it for today. Yeah, have a great day. Yeah, if you want to catch up one-on-one, just ping me and we can catch up one-on-one.